All right, for the last section in chapter 6, so this is a little application of how you can do the normal curve or normal CDF by using it as a way to approximate a binomial distribution. So instead of using binom CDF and binom PDF, what we're going to do is use normal CDF for all of these different problems. So again, if you remember, some advantages to normal CDF over binom CDF is we had a lower bound and an upper bound, so we didn't have to think about all that 1 minus stuff and things like that. So there are some things that we have to verify in order to make sure this is true. So if we take our probability of success, multiply it by n, it has to be greater than or equal to 5. If we take our probability of failure, multiply it by n, it has to be greater than or equal to 5. So we do have to find our mu and our standard deviation because we need those for our normal CDF, but we talked about those back in chapter 4. And then I mentioned this, I think, a little bit when we were talking about normal CDF. So we will have to tweak our x values a little bit. So for normal CDF in general, remember, we didn't worry about less thans or greater than or equal to or anything like that. But here we will, and we're going to have to modify our x values accordingly by either subtracting 0.5 or adding 0.5, depending on whether we want to include that particular value or not. And then once we've done the modifications, then we'll be able to find our probability related to these guys. All right, so let's take a look at practice 1 here, and we'll kind of work through this one together. So a study shows that 12% of M&M plain candies are yellow. A random sample of 50 such candies is randomly selected. First, identify N, P, Q, and X in this binomial distribution. Can we use a normal distribution to approximate this binomial distribution? So for this one, our N is, of course, going to be 50. Our P is going to be the 0.12. Our Q is going to be minus 0.12, which will be 0.88. And our X is going to be the probability of getting a yellow. So X is going to be pretty much the numbers 0, 1, 2, the whole way up to 50 in this case. So, we could get all 50 of them be yellow, but that'd be pretty unlikely in that case. But that's what our X's are going to represent for this. So next, what we have to do is verify that we can actually use our binomial distribution or normal distribution on this. So we're going to do our N times P, which is 50 times 0.12, and see if it's greater than 5, and then do our NQ, which is 50 times 0.88, and see if it's greater than or equal to 5. All right. Oops, I don't want those there. Hold on. All right, so 50 times 0.12 is 6, which is definitely greater than 5. And then 50 times 0.88 is 44, which is clearly bigger than 5. So in this case, we can use our normal CDF as a way to approximate this binomial distribution. And so remember, we could do this whole thing using binom PDF and CDF. I'm just showing you this is a nice example of how you can use the normal CDF for this. All right, so in this case, we're trying to find what's the probability that more than 8 are yellow. So what we're looking for is the probability of X being greater than 8. So since we don't want to include 8 in our probability, when we set up our normal CDF, then what we're going to do is take 8 and add 0.5 to it so that 8 isn't part of our answer. And since this is a more than, this is going to be our lower bound, and then some ridiculously big number for our upper bound. And then we need our mean and standard deviation, which I realize now I forgot to calculate, so let's do that real quick. So our mean is going to be the 50 times the 0.12, which I guess I did calculate here. So this is our 6. And then finally our standard deviation is going to be the square root of 50 times 0.12 times 0.88. so if I throw that in the calculator real quick here, 50 times 0.88 times 0.12, so it looks like we get 0.75 for our standard deviation. All right, so now, and we're not using central limit theorem or anything like that on this. This is just normal old chapter 5 stuff. So we're going to get 6 comma 0.75. And so again, we'll just type that in exactly the way it's written. And then if you wanted to, you could do this in a similar way using Binomial CDF just to compare them. But I'll leave that for you guys to kind of type in here. I just want to make sure we get them set up right. All right, so for B, what's probably that most 10 are yellow. So in this case, we're looking for x is less than or equal to 10. So in this case, we do want to include 10 in our calculation. So 10 is going to be our upper bound. So I want to pick some ridiculously small number. But since I want to include 10, I'm going to add 0.5 to this to make sure 10 is in the interval that we're looking at. And then finally 6 and 0.75. And so again, I'll let you guys type this in just to make sure you got the hang of it. All right, so for C, suppose in one of our surveys we found at least 6 yellow M&Ms out of 50. What should we conclude about the 12% rate that they originally claimed? All right, so let's take a look here at what we've got. So if we do our at least 12, so we're looking at the probability that X is at least 12, so that's going to be, or at least 6, so 6 or more. So X is greater than or equal to 6. So if we do our normal CDF, so 6 is going to be our lower bound, but we want to include 6. So we're going to drop down by a half to 5.5. And then some ridiculously big number, comma 6, comma 0.75. All right. So let's throw this in the calculator together since this one's asking a different question. So we've got our normal CDF, 5.5, comma some really big number, comma 6, comma 0.75. And so in this case, we've got a probability of 74.75%. 74.75%. And so if you think about 6 out of 50, then that's the same thing as like 12 out of 100, which would be about the 12% that they're claiming that we get. So the fact that we're getting 74.75% tells us that that means there's a pretty good chance that their probability really is true. Now, if this would have been really small, like 0.05 or smaller, then that would probably mean that the probability that they're estimating is not realistic in this case. But that 12% seems to be a pretty legit claim if we're getting almost a 75% chance that we're going to get 12 or more, or 6 or more M&Ms out of a pool of 50 in that case. So that looks really good. So nice. All right, so again, just to kind of summarize when we're going to use each and every one of these. So the only one I didn't do an example of was the exactly one. So remember, we're never going to use normal PDF. So the way we deal with an exactly is if we were looking at the probability of getting 8 exactly, then we would do like normal CDF, 7.5 to 8.5, and then whatever our mean and standard deviation was. So otherwise, I kind of addressed all the other ones there. So let's try practice 2 and practice 3, and these should look familiar to you. These are actually the same examples from chapter 5. So if you wanted to compare your answers to see how close they are. Now again, they won't be exactly perfect, but again, this is just a nice little application of how we can use a normal CDF compared to a binomial CDF or binomial PDF. All right, well, good luck, everybody. And so when we're finished these 2 examples, we'll be able to dive in and start doing the homework and stuff. So good luck. Let me know if you have any questions.